I'm hoping you can see my screen now.
Yes, excellent.
Yes, excellent. All right, thank you very much. So thank you, Marco, for this opportunity. As Marco mentioned, my name is Jeen Broekstra, and I will be talking a little bit about Eclipse RDF4J and how you can use that to work with RDF in Java. In the next 50 minutes, if I get confused or talk really slowly, it might become an hour. I will show you a little bit of the history of the project, and I will go into some code examples of different aspects of the project, and also show off a little bit of some of the stuff that we do at my employer MetaFactory as well, because it is kind of relevant in the sense that the entire platform is based very much on RDF4J, and it highlights some of the things that you can actually do with it at a higher level. Before we get into all of that, though, just a very brief about me again. As Marco mentioned, I'm a principal engineer at MetaFacts, which is a German company involved in knowledge graphs and linked data platforms. I am a Dutch Kiwi living in Melbourne, Australia, which means that I was born in Holland, moved to New Zealand about 10 years ago, became a New Zealand citizen, and then about 3 years ago moved to Melbourne, where I have been ever since. I'm one of the original designers of Sesame, together with a couple of other people, including Arjon Kampman, who I should definitely name my name because he was responsible for more than 50% of it. And I'm also the current project lead of Eclipse RDF4J. Now, before we get into the meat, I wanted to take you through a brief history of RDF4J. And like Marco mentioned, originally the project was known as Sesame. So let's talk a little bit about that. We have to go back way back to 2001 when Sesame was born. And the birth of Sesame occurred as part of a European research project called Onto Knowledge, and more specifically as part of a very small Dutch startup company called Administrator, later called Aduna, where I had just started working as an engineer at the time after finishing my master project. And at the time I was sort of on the fence whether I should be doing a PhD or whether I should be going into getting an actual job. Whereas where the boss of Aduna said to me, why not do both? We've got this European project coming up. We're going to be needing to do some research and development. It would be a really good fit. So the rest is history. I got to be a PhD student and work on this cool thing, Sesame, which was originally one of the main topics of my PhD project. So originally the project was very much this online thing. This was way before there was such a thing as Sparkle. So we are talking about having our own little query language. It was called RQL. We actually it was very inspired by something that was developed in ICF Forth, a Greek university research institute. We sort of made it our own, turned it into a query language called Circle, SERQL. And then in 2002, we decided that it had been a proof of concept long enough, and we decided to make it an open source project. This is where it became OpenRDF Sesame. And this is also where the first shift sort of occurred from being this online service to more becoming an API and a toolkit for working with RDF in Java. In the next few years, this sort of continued. In 2003, we introduced the Rio parsers as sort of their own thing, which was still part of the Sesame framework, but you could also use it independently to read and write one of the many syntax formats that exist for RDF, because you can never have enough syntax formats. If we then fast forward a little bit, in 2008, we decided that we had built enough. We threw it all away and started again. Sesame 2.0 was a complete redesign of the entire framework. This is also around about the time when Sparkle 1.0 became almost a recommendation, I want to say, or already was a recommendation. Actually, we were involved in the working draft specifications of that a lot as well. Fast forward even further, the next few years were maintenance releases, adding new features, all of that. And then around about 2016, Aduna as a company had sort of faded into the background a bit. There was a bit of uncertainty about where the intellectual property rights for all of this were. And there was a lot of discussion about that. And we decided to donate the entire project to the Eclipse Foundation. And that is where OpenRDF Sesame became Eclipse RDF4J. The focus was very much on being this API and toolkit for modern Java, and your mileage may vary on what modern Java means, but for us, it meant things like being able to use lambdas, being able to use optional and the stream API and that sort of stuff in a way that makes working with this toolkit a pleasure for a Java programmer. Another big thing, and this was actually very much helped by moving to a vendor-neutral stewardship like the Eclipse Foundation, was that we very much wanted it to be a vendor-neutral API. So rather than being the product of one particular company, even if it is open source under a very liberal license, we wanted it to be very much positioned as this vendor-neutral thing that you can use to communicate to any particular RDF data store or project. And that's roughly where we are today as well, I'd say. We do regular new releases. We have a very dedicated core committed team, loads of more incidental contributors as well. Current focus in development are very much in the area of improved Shackle support, of which I will show a little bit later on. Sparkle 1.2 is on our radar to have a look at, which is a community effort to further improve the Sparkle standard. RDF Star and Sparkle Star, we actually recently did a release of with a first experimental support for that, which unfortunately I am not going to show in any more detail because I ran out of time and slides. And another big thing that we are actually looking into is to make sure that we keep up to date with Java itself, because the current releases of RDF4J are built and compatible with Java 8 up to Java 11. But we want to make sure that with new releases, we keep updating so that you can use the framework on the most modern Java releases without sacrificing backward compatibility. So that's for the history of it a little bit. Maybe the next thing to have a quick look at is what actually is RDF4J. There's two major subsets into which RDF4J falls apart. One way of looking at it is that it is this collection of Java libraries for working with RDF data. So it's a set of APIs, a set of Maven modules that you can use in your own software application project, with functional libraries that allow you to do things like reading, writing, creating, updating, converting between all these different syntax formats, storing data in a database, doing Sparkle queries, updates, working with remote Sparkle endpoints. It offers some out-of-the-box transactional storage, in particular the native store and the memory store. Added and probably the most important thing of all of these bullet points is, again, this vendor neutral API for connecting with any sort of RDF store or database. The other subset of what RDF4J is this set of ready-made tools that you can use, that you can download and install and run and do things with. The three principal tools in our set are the RDF4J server, which is an RDF database manager that you run as a web application, and that allows you to expose RDF databases as Sparkle endpoints. You can do queries against them and that sort of thing. The Workbench, which is its companion UI, which allows you to manage those databases, configure them, edit those queries, and all that sort of thing. And in addition, there is also something called the RDF4J console, which is a command line tool, something that you run in a terminal and allows you to do all sorts of quick tasks to do with RDF files or with connecting to databases and running queries and that sort of thing. We'll see a little bit more about all of that later on in this talk. Now, Marco assured me that everybody on this talk would be more or less aware of what RDF actually is, and said it's not an introduction to RDF. You don't have to do about any of that, but I couldn't resist to, just in case anybody has become sort of a little bit rusty on this thing, what is RDF? So there's one slide, maybe two in here about what RDF is. And what the essence of it is, it's a graph data model, right? We have a little graph here, 4 nodes, 3 edges, where Jeen is the project lead of RDF4J, and RDF4J is a project, and Jeen is a person. That's not very exciting. What makes RDF RDF? It's not the fact that it is a graph data model, it's the fact that you use IRIs as a means of global identification. That's really the core of the RDF data model. So all these things where I now say Jeen or project lead or RDF4J or personal project, in reality are URIs or IRIs, globally unique identifiers. Why is that important? Because it allows decoupling of information, decoupling of data sources. Information about me as a person can live somewhere completely different from the project, and information about the actual vocabulary that we use, and namely that there are such things as persons or project, can live somewhere else again. All of those things can be completely distributed. Just the fact that we use the same IRIs to talk about the same things is a very simple yet very powerful feature. This, to me, is what RDF is all about at its simplest level. There's loads of additional details about RDF, like blank nodes and containers and collections. We're going to cheerfully ignore all of that and just say, this is what RDF is. Graph data model, IRIs, all you need to know. Right, getting back to RDF4J. I mentioned that it is a modular set of libraries. Here's sort of a high-level overview of the architecture. The dark orange boxes are those the main APIs, and I want to say salmon boxes are sort of the filling in the implementation components that fit under those various APIs. So if we start on the left, Rio or RDF.io is the parser and writer API of RDF4J. It is completely streaming, which means it is very scalable and quite fast. It can do very strict validation for you if you want, but it can also be configured to be very forgiving if you need to work with very dirty data. And as you can see, there is a whole host of different syntax formats that we have specific parsers and writers for. In the middle there is something called the model API. This is really the foundation of the framework in a sense. It is the Java representation of RDF, namely RDF statements and values and IRIs and literals and all of that, as well as RDF graphs, which we actually rather confusingly call models as well. I won't go into the details of why we do that, but we'll see a few examples of that later on in this talk. And then on the right, we have the repository API, which is the thing that you use when you want to work with RDF data at scale. This is where you communicate with databases, where you do Sparkle queries or updates, where you start and commit transactions. And the repository API is really an abstraction layer on top of any sort of scalable RDF data source, whether that is an embedded database exposed via a sail, whether that is a remote database living on an RDF4J server, or whether that is an even more remote database living at some Sparkle endpoint, either public or private. Then the last bit that I briefly want to talk about is this dark orange box in the middle there called the Sail API, which is also a public API, but is not really intended for direct use by you as an application developer. It is meant as a decoupling point between the more functional APIs and the nitty-gritty details of the particular data store that you're using. So it offers various implementations for particular data stores. So there's the memory store and the native store, which are databases that RDF4J supports out of the box. But any kind of custom store can be in there as well. So as an example, OntoText GraphDB, for example, is a Sail implementation. On top of that, the API has been designed to be sort of stackable components. So on top of that, you can stack things like reasoners for RDF schema inference, for Shackle validation, any sort of custom inference would fit in there as well. And there are other kinds of extensions that we offer as part of the Sail modules as well. For example, full text search using a Lucene API or Elasticsearch. There is, and I have to be careful here because Marco is on board. There is some GeoSparkle support. I won't claim it's anywhere near complete, but there is some support for geospatial querying in the framework, and that lives at that Sail level. And then last but not least, there is this notion of federated query, which I will show a couple of examples of later on in this talk as well. Right. Now let's have a look at some tools. And the first tool that I should probably tell you a little bit about is the RDF4J server. So what is the RDF server? It is an implementation of something called the RDF4J REST API. What is the RDF4J REST API, you might ask? Well, it is an extension of something known as the Sparkle 1.1 protocol. Sparkle 1.1 protocol is a W3C recommendation. It's basically the thing that people mean when they talk about Sparkle endpoints. It is a REST API for sending Sparkle queries and updates and receiving results of that. Why am I calling the RDF4J REST API an extension of that? Well, for two main reasons. First of all, the RDF4J REST API offers full transactional support, which is something that is not part of Sparkle 1.1 protocol. And it offers several additional endpoints for doing database management operations, like creating a new RDF store on the fly, or configuring it, reconfiguring it, deleting it, that sort of thing. I should probably say that there is a little bit of history and legacy there as well. Parts of the REST API predate the Sparkle 1.1 protocol. Which is why some of those things overlap a little bit as well. But just to I was going to say I'm going to quickly demo this by doing a curl request, but at the last minute I decided that that is really too boring. So I will just skip straight on and to something called the RDF4J Workbench, which is a client tool for the RDF4J server. And this is something that I will actually try and demo live. So if you bear with me for a sec, I'll briefly switch to a different screen share. There we go. You should be able to see my browser now where I have the RDF4J workbench open. And as you can see, this is a workbench running on my local machine connected to a local RDF4J server on which there is one particular database called artists. So I'll just click that to go into it. It tells me there are 30 statements in there. I uploaded this huge data set. And I just very briefly wanted to show you a couple of the things that you can do with this tool. Well, first and foremost, of course, you want to be able to do queries. So let's have a look. There was actually here's a query I prepared earlier, but let's make it slightly simpler. Let's do a very simple query to ask for all subjects of a particular type and limit ourselves to 100, because it is always good to limit yourself if you don't know what you're querying. And you get back a result. In this case, a couple of results about painters and their types. So Picasso is an artist, Van Gogh is an artist, and Guernica, Starry Night, Sunflowers, and Potato Eaters are all paintings. The nice thing about the workbench is that it offers you kind of nice features to sort of explore your data set a little bit. So you can, for example, click Guernica, and then you get a little bit of an exploration to say, well, what do we actually know about Guernica? It's of type painting, it has a label, it has a technique, oil on canvas, and Picasso is the creator. You can sort of click your way through the data set very easily in that way. Another nice feature that it has is that it allows you to save queries. So here, for example, we have a query, paintings and their creators, which I saved previously. So I have it bookmarked in a way, and I can just execute that immediately. What this query does, by the way, is just get back paintings and their titles, and then the surname of each of those creators of those paintings, but only if the painting has a Dutch title or a title where the language is not known. So if we execute that, this is all very contrived, of course, but it's just to show the kind of things that you can do with this kind of tool. The other thing, as I said, it allows you to do some database administration, so you can create a new repository. There's a whole host of different options here, and these are all variations of different sales stack configurations that I mentioned before. But the thing that I actually want to very briefly show you as well is that you can also use this thing to connect to any sort of Sparkle endpoint. So, for example, if we decide we want to have a nice interface to do some queries on DBpedia, we could just do, I happen to know that that is the Sparkle endpoint for DBpedia. It's not really hard to remember. So we create that. And now we can do a simple query and say, give me all I can never remember this from the top of my head, but I think that's right. Let's see what we get. Hey, here we go. So we now did a Sparkle query on DBpedia, and we get back a result. So it's a very nice and easy way to sort of explore not just your own databases, but anybody else's, if they are silly enough to expose them. Right. Going back to the slides. I think it's that one. There we go. So the other tool that I briefly wanted to mention is the RDF4J console. I'm not going to demo that one live, but it is a nice one to give a little bit of love to, in that it allows you to do a lot of things with RDF from the command line. Verify and convert RDF files, so you can verify that the syntax is correct. You can count how many triples there are in there. You can convert from one syntax to another very easily. You can create a local database on the fly, load data into it, and try out your Sparkle queries. It has a lot of functionality for that sort of thing. And you can also, like the workbench, use it to connect to any sort of public Sparkle endpoint. Right, so far I've really talked about the tool aspect of RDF4J, but the title of this talk was working with RDF in Java, so we should probably start doing some coding. So let's dive into that straight. Starting at the beginning, you have an RDF file, you want to do something with it. The ReoParser is really your one-stop shop for that kind of thing. It allows you to very quickly load in a file and either convert it to a model or something else. And I will actually show a couple of quick code examples of this live if I can get this screen sharing thing down. So we'll go to Eclipse. Here we go. Of course, as an Eclipse project, we have to use Eclipse IDE. No, that's not true. I mean, some of our developers use other tools, but I happen to like Eclipse. Here's a simple example. We have a file, example data artists, which will contain the same information that we saw earlier in the little demo that I did in the workbench. We open that file as an input stream. We're telling the parser that it is a turtle file, and then we want it to be parsed and put into this model object, which is, and I'm not sure if you can see this hover over thing if I do that during screen share, but what a model basically is a Java collection implementation. It's a set of statement objects. So you can use it like any other Java collection, like a list or a set, but you can also do some additional Java specific, RDF specific stuff. In this particular case, we are just iterating over everything and printing it to stand it out. So if I run this very quickly, just to show you that I can actually program Java a little bit, what you see is just the internal representation, the internal string representation of the RDF statements that were in that file. So here's Picasso, is of type artist, and has as his first name Pablo, and as his surname Picasso. This is not particularly exciting use for it, but it goes to show that actually reading in a file, doing it, and then doing something with it is only 2-3 lines of code. Slightly more interesting maybe is using the ReoParser to do a conversion. So for example, we have our turtle file again, and we want to convert it to JSON. So let's run this. So we have a parser again, it passes it to a model, and then we pass that model back into a Rio writer in this case, which we tell to produce RDF4J, RDF JSON. So if you run that, what we get is, looks like JSON to me, same data, different format. And of course, I mean, what I'm showing you here is actually not particularly scalable, because we are first reading in the entire file into an in-memory model, and then we're writing that entire model back to file again, which works fine because this particular file is only 30 statements. But if you want to do this with something that contains several hundred million statements, it becomes a bit trickier. So obviously you can do this kind of thing using completely streaming approach as well, where you set the parser to just immediately let the writer handle everything that it outputs. This is kind of a thing that you will see throughout the RDF4J framework. Anywhere where you're dealing with large amounts of data, we typically offer an option, and usually it's even the default option, to work with that data in a streaming fashion so that you do not have to fully materialize the big amount of data in memory, but you can sort of pass it on and let whatever is processing it process it in a scalable fashion. Another thing that I might as well briefly show while I'm here is what you can do with these model objects. I briefly mentioned that they are sort of Java collections with a little bit extra. One of the little bits extra that you can do with it is using things like filters to sort of say, well, I only want the statements in your model, in this particular case, that are RDF has label as the predicate. So this will filter my model on only the statements that are label statements. And just to sort of very boringly talk you through this bit of code completely, we get the objects of all those statements. We check that they are literal values, just in case. And then we check, do they have a language tag, those literals? And if they do have a language tag, is that language tag English? And if so, then we print it out. So if you run this, you will get, not very surprisingly, a couple of results, namely Starry Night, Sunflowers, and the Potato Eaters, all English language labels. Now this is all very classic Java. We're doing a for loop, and you know, some nested ifs and that sort of thing. This is maybe a little bit more modern, but just to give you an idea of, if you are more functionally or more Lambda inclined, that you can do that as well. And this is something that we've worked hard on over the past 2 years, I want to say, to sort of update a lot of parts of the API to make them more flexible and more useful. So this bit of code does exactly the same thing as the previous bit of code, but it uses the new Java streaming API combined with Lambda functions rather than these nested if statements to do all our mapping of and filtering. As you can see, we get all the objects, we stream over them, we filter on everything that is a literal, then we check that there is a language tag, we check that that language tag is equal to English, and then everything that is left we print out. And just to show that this does exactly the same thing, it does exactly the same thing. Now this is all nice, and if you only have small data sets to work with, then this will be fine. But as soon as you start working with RDF data at scale, you'll need something a bit beyond just having an in-memory model. And this is where the repository API comes into the picture. So the repository API is this JDBC-like or JDBC-inspired, I want to say. It's a transactional interface for RDF databases, and it allows you to work with RDF data at scale, doing large bulk uploads, doing queries on huge data sets, handling transactions and transaction isolation and all of that. And like in any transactional data store, these transactions are atomic. Like, I mean, none of this will be a big surprise to anybody who's worked with anything like an SQL database or anything like that. So typically how you work with this is you open a connection on your repository, you begin a transaction, and then you do one or more operations and you commit. And if something goes wrong, either everything is rolled back, or and if nothing goes wrong, everything is committed at once. RDF4J repositories support concurrent read and write. These transactions can have different isolation levels, and this is all fairly straightforward. I'm not going to be demoing this one live, although, and I will check this with Marco later on. Some of the code examples that I have prepared, I will make sure that they are put in a GitHub repository somewhere, so that if somebody wants to sort of download these and play with them a little bit, they are available for you to have a look at. That shouldn't be hard to set up. Let's look at something maybe slightly more exciting. Shackle, the shapes constraints language. It allows you to specify rules on what your data should look like. Things like all persons must at least have one first name. And how RDF4J supports Shackle is through a component called the Shackle shell. It's a stacked shell that you layer on top of any sort of database. And what it does is it validates any sort of incoming new data against the Shackle rules that you have specified when you're doing a transaction and on commit of that transaction, and we'll actually show a quick demo of this as well, just to sort of belabor the point. No, that's a different one. Sorry. Here we go. I'm getting ahead of myself. Shackle. So what do we have here? We have, as I said, here you can see how we stack shells on top of each other. It's basically just an in-memory database that we wrap with a Shackle cell component, and then we give that thing to a repository to create our database. As an aside, there are many different ways of creating and managing repository objects in the RDF4J framework. Here, I'm just creating them with a constructor, but in many application scenarios, you would use something like a repository manager or a repository provider object to keep track of the different repository objects that you have and sort of share them throughout your application code. But for the purposes of this demo, we'll just use this very simple way to sort of create them on the fly. Back to Shackle, we need two types of data. First of all, we need our rules, or shapes, as we call them. So we've got a file here with Shackle rules. We've got some data as well. It's the same data that we were talking about earlier, and I just realized that I need to very quickly fix something in that. So close your eyes for a sec while I make a mistake in our data. There we go. This one I prepared earlier. Going back to Shackle, if we have a quick look at our shapes file. So I've created a very simple shapes file. There's one shape in there corresponding to one rule. And what that rule is it's saying that every instance of the class painting, if it has a label property, its language must be unique, which means that something can have more than one label property, but if they have more than one label property, those two label properties must be in different languages, is what this says, which is sort of a valid thing to say. I mean, you might want to have one unique name for a thing in each different language. So if we go back to our code, as you can see, you connect to this this repository like you do with any other repository. And the first thing we do is we add our Shackle constraints because the data store needs to know those rules. Obviously, this is something that you typically only do once when you set up your repository, and the way you tell it to recognize these as not just any old RDF data, but as actual Shackle constraints, is that you add them to a particular named graph, namely the Shackle shape graph. Once we've done that, we can actually add some data, and it will automatically validate that data after it's tried to commit. And the way it's set up is that commit will fail with an exception if the data that you're trying to add does not conform to the Shackle constraints, and then you can inspect that exception to get the cause, and that might be a validation exception from which you can then extract a report. This is fairly low level extraction of validation results. There are more advanced ways of doing this currently supported and also in the making. But I just wanted to sort of show the low-level code example. So if you run this now, what you will hopefully see is that it fails. Yes, it does. We're getting an error. Validation failed. Oh no. Here's a validation report. It's an RDF model, conform the Shackle standard. It tells us that the data that we try to add is not conform the Shackle shapes that we know about, and it tells us that a particular node, namely this thing, potato eaters, fails on the fact that the unique language constraint is failing. Which, if you remember what I just very quickly did when I edited this file, here are our culprits. So we have 2 labels for potato eaters. One is actually English, the other one is actually Dutch, but we've mistakenly given it an English language tag, which is kind of a common thing that could happen if you are doing a lot of copy pasting and that sort of thing. So if we remove this, save it, and then run the whole thing again. Okay, presto, nothing happens, which means that this time around our data was completely valid and it was added to our database. There's a lot more to say about Shackle and the expressivity of Shackle and all of that, but this sort of goes to sort of give you a general idea of how you would use the Shackle cell in code. Moving on, another interesting feature that is fairly new to the framework is FedEx, which is the Federation module. And what FedEx allows you to do is treat any combination of Sparkle endpoints or local databases or remote databases as a virtual repository. It allows you to do Sparkle queries on that thing without having to say, and this bit of the query you have to get from that particular data set, and this bit of the query you have to get from that particular remote Sparkle endpoint. That is all handled under the hood for you. It does very clever query planning and optimization to route relevant part of those queries to the various Federation members. And what you can use this for, whoa, that was, I need to go back. What you can use that for example, is if we have a little example here. Here I've set up a little federation with just 2 Sparkle endpoints, namely DBpedia and Wikidata. And let's say we want to do a query where we combine some data from DBpedia with some data from Wikidata. So for example, I know that if we look at this Sparkle query, you can actually see it. I know that DBpedia contains information about which countries are members of the European Union. I know that there is a mapping between countries in DBpedia and countries in Wikidata. And then in Wikidata, I know that Wikidata uses these very cryptic property names, but trust me that this is the property name for the GDP, the gross domestic product of a country. So what this query does is it gets all the members of the European Union, gets their GDP, and orders them by from highest to lowest. So from looking at the query alone, it wouldn't be immediately obvious that this query is two different data sources. FedEx handles all of that on the fly. So if I run this quickly, and if you know how many member states there are of the European Union, it is, and I'm taking a bit of a risk here doing this as a live demo because these are public endpoints and they are occasionally down. Oh, here we go. That was quick. 28. That's not right. Ah, right. DBpedia thinks the United Kingdom is still in there. Anyway, here you see the members of the European Union ordered by their GDP. Germany at the top, followed by the United Kingdom, followed by France, and Malta is at the tail of it. So the nice thing about this is we've done a query that transparently queries information from DBpedia, namely which countries, and from, in this case, Wikidata, which tells us what the GDP of those countries is. So this is a very powerful thing that you can do, not just with two public Sparkle endpoints, but also if you want to combine your own database with any sort of public data set exposed as an endpoint. And sorry, I'm looking for the screen share button and I keep losing it to switch back to my slides. There we go. So as you can see, it's the FedEx thing is a repository in and of itself, so you can use it as any other repository. So in any scenario where originally you were working with your own database, and then later on you figure out, hey, maybe I want to combine this with some other database, you can pretty much always just replace your repository configuration with the FedEx configuration and just transparently query over both, hiding the complexity without having to rewrite any of your Sparkle queries, which is a very nice feature, I think. All right. This has sort of been a very quick tour of some very simple ways in which you can use the RDF4J framework. There's a lot that I've glossed over and a lot of features that I really wanted to put in there, but sort of had to leave out in the interest of time. One thing that I do briefly want to sort of highlight a little bit is take it up a little bit in terms of where all this leads to. So if I share my browser with you for example, for a second, is something I want to show you, the kinds of things that you can do with this. So I mean, this topic was all about RDF4J, so let's see what Wikidata has to say about that. In terms of a knowledge graph, RDF4J, it's open source software. It has a particular programming language, Java, no surprises there, I guess. And then, well, let's see what else we can find out. So who uses this? This is where I sort of start doing a little bit of, I'm very proud of recently having become part of the Meta Factory team, which is why I'm sort of doing this. But it is sort of a nice way of demonstrating that the kinds of things that using RDF and linked data and the RDF4J framework as a basis allow you to do are things like this kind of interactive exploration of any sort of data set, in this particular case Wikidata, but you could of course do this on any type of RDF data set. Oh, hey, there's me. Look at that. What else do we have here? Who's my boss? He should be in there. Oh yeah, Peter Haase is the CEO of MetaFacts. He's also an author, I think. So he's written several interesting articles. So comparison of RDF Goerli languages was just actually something I co-wrote with him. So that's nice. So, I mean, obviously this is sort of a contrived toy example, but it kind of shows the power of using this this kind of functionality. And just to show one other kind of thing is that, like I mentioned before, this notion of combining different data sources transparently is sort of you can sort of take that to the next level. So if we look, for example, like at the place where I live, which is Melbourne, again, we have a knowledge graph. And if we go to the external links tab, it immediately tells you things like, all right, there's loads of open data sets from all around the world that have something to do with Melbourne. There is apparently we occur in the French Vigilia. I have no idea what that is, but we're also in the Australian Statistical Geography Standard. Quora mentions us, Vic names, which is probably something from the state of Victoria, of which Melbourne is the capital, etc., and so on. And the other thing that you can do is combine it with any sort of API, really, as long as you combine it properly and expose that data as RDF. So, for example, here it's been tied into a weather API to tell us that we're probably going to have a nice weekend, which is good, because we might actually be able to go outside again this weekend as well. Moving back to my slides, I'm going to bring it to an end. except for briefly mentioning where we are as a project right now. Our current focus areas are very much around further maturing the very experimental support that we now have for RDF Star and Sparkle Star, which are proposals for extending the basic RDF model with ways to annotate RDF triples. It's sort of a missing link between the RDF data model and the property graph model is one way of looking at it. And there's a lot of literature and discussion online. The latest RDF4J release has some minimal support for this already. So if you are interested in that kind of thing, definitely try it out and tell us what you think. Another big focus area at the moment is performance improvements, and in particular on the native store and on communication with remote clients. We've made some big improvements already. Further improvements and extensions of Shackle support for different use cases is something that we are paying a lot of attention to. And another big feature that we recently released in a first version and hope to further improve is that we are exposing the query plan with an explanation which allows you to do analysis on your queries. Like you have a particular query, it is very slow. This query plan explanation can tell you things like where are the bottlenecks and what could you potentially do to speed up that query, which is going to be a very powerful thing. It already is, in fact. I think that's more or less all I have time for here. Rather surprisingly, I actually managed to keep it under 50 minutes. Every time I practiced this, I went over. So I talk faster in real life, apparently. If you want to find out more, there's obviously the community website at rdf4j.org. You can find us on GitHub, which is where our code repository lives. There is community support in the form of a Google group where you can email us. There's the issue tracker on GitHub where you can log your feature request or your bug report, or even if you have a question and you prefer not to use the Google group, you can. We're fine with you using the issue tracker for that. Obviously, we would very much welcome you to become a contributor as well. If you find use in the project, but there is this little thing that bothers you, let us know, get in touch, submit a patch, become a contributor. And contributing doesn't necessarily mean coding either. I mean, if you have ideas about how to improve the documentation or maybe design ideas for the look and feel of the workbench or anything that impacts on the project, then we'd love to hear from you, is what I'm saying. That's all I pretty much had, except for a brief shout out to some major contributors and sponsors. MetaFacts, my employer, like I mentioned, who deserves some kudos. Ontotext, who have been very active and staunch supporters in time and resources over the years for the project. And in particular, the RDF Star and Sparkle Star stuff has been done in no small part by the Ontotext developers, and they've contributed that back to the project, for which I thank them. And my core and the core committer team, I should thank those people as well, especially Havard, who's been our Shackle wizard in particular, and been doing a load of performance improvements as well. There's Bart Hansens, who does a lot of improvements on things like the console and general usability and updating of and keeping the code clean. Andreas Swarta, my colleague at MetaFacts, who is the main developer of the Federation module that I briefly talked about, and Damian of Ontotext, who, like I mentioned before, has been one of the main contributors on the RDF Star and Sparkle Star stuff. Apart from that core committer team, we obviously have loads of individual contributors as well, too many to mention, but they are not forgotten. And we'd love you to become part of that family. All right, with that, I'm going to leave it and I'm going to hand it back to Marco. Thank you very much for your attention.
Excellent. Thank you, Jeen. That was a great presentation, a great overview of the RDF4J project. And with that, we're actually having a Q&A session now. I would like to thank the participants who stayed for the entire talk. That is very unusual. We had actually, I think, one person left, and that was a duplicate. So, yeah, how this works now is you will have to raise your hand, and then I will unmute you. I think I can request the host status. So let's see. Oh, I see. Okay. Actually, Jeen, if you could assign the moderator host.
Yeah, I'll make you host again, Marco. How's that?
Excellent.
All right, here we go.
Okay. Now
you should be the host now.
So I have just deselected Christian. Christian, can you please ask your question?
Yeah, thanks, Jeen, for this very instructive talk. I wonder, could you say a couple of words about named graph support? Or is this perhaps eclipsed or soon to be eclipsed by RDF star?
Interesting question. Named graph support goes back quite a ways. Actually, I forgot to mention this, that it actually, in RDF4J, it's called context, which sometimes confuses people, but I think it is remiss of me not to mention this briefly, that if in any sort of RDF4J documentation or API you see this thing called context, think named graphs. But to answer your actual question, I don't think RDF star is going to replace named graphs, although they fulfill slightly similar roles. The use case is a little different, because what named graphs are in particular are a grouping mechanism for collections of statements that belong together, whereas RDF star is really about adding additional information about one particular triple, one particular statement. That's the main difference. So yes, there is some overlap, but I don't necessarily see them as one replacing the other. Does that answer your question?
I think that
yes, thanks.
If you take the questions, Jeen, please mute yourself. Otherwise, we will have an echo.
Sure.
That was mentioned by Morten here. Thank you for bringing this to my attention. Now, are there any other questions? Please raise your hand. Let's see. I see a hand by Andrew. Andrew, please go ahead.
Thank you, Marco. Jeen, thank you very much for your presentation. I have a question about transaction support. Is this going to be standardized in Sparkle 1.2, or is this feature going to remain unique to RDF4J?
Thank you, Andrew. Good question again. First of all, I don't necessarily think that the feature as it is unique to RDF4J, because I'm pretty sure that Jena has something very similar. It's just not standardized. We each have our own solution, which is also, I would say, a very good case for maybe picking this up as part of a standardization effort. I know there is a feature request within the Sparkle 1.2 community group for standardization of a transactional mechanism in the Sparkle protocol. But I must admit that I haven't looked at it in a while, so I don't quite know what the status of that is or how far along that is. I know it's there. I know that our particular protocol is an input in that proposal, but I'm not immediately aware of where that has been taken beyond being proposed. Maybe Andy knows a little bit more about that. If you have the inclination to answer that right now, I'm sort of putting you on the spot. Apologies for that.
No, that's okay. So first of all, Sparkle 1.2 is a W3C community group that is mainly centered around gathering requirements and fleshing out some details of possible changes to Sparkle in the future. There's no specific timescale for doing that, nor has W3C elected to make it a working group at this stage, but given the way the newer processes in W3C works, the first steps are always to gather use case and requirements and flesh out the details to show that there is a long-term viable working group, rather than the old style, which was to do a lot of that work during the working group cycle. There are about, I can't even remember the number, 100 odd issues raised, everything from small things to large things, and the transactions is certainly on one of that. I don't think it's particularly controversial in what it would do or the impacts on that. So I think that is proceeding as well it does. The main thing anyone can do is contribute to that debate, but the more energy, the more discussion there is around features, the more progress they make. And W3C very much want to see beyond the level of a few member organizations claiming that things need to be done, to actually show that for them, and W3C have limited resources and can't run that many working groups at the same time, and we have to make the case to run one. And Sparkle 1.2 is that. If you're interested, there's a community group, you can sign up, you can contribute, and the issues are on GitHub.
Thank you, Andy.
Okay, are there any questions? Please raise your hand. Okay, Morten, please go ahead.
Hi, Jeen. Thanks for the presentation. My understanding is that RDF4J doesn't have any reasoning support, any L2 reasoning support. Is that true? And if so, are there any plans for reasoning in the future?
Thanks, Morten. Yes, that's true, at least out of the box. I mean, there is obviously support for RDF schema inference, but it's fairly charitable to call that proper reasoning, I guess. Having said that, there is the OWL API project, which, unless I'm much mistaken, is RDF4J compatible, which offers an OWL view on top of the basic RDF4J API. So we've sort of left that to the side a little bit and decided to let other projects who make it more of their prime focus, because it is a complex topic, take that in hand. And also there are commercial solutions or even free, though not necessarily open source solutions in that space. So Ontotext GraphDB, for example, has a free version which supports L2 reasoning out of the box already. So I think the short answer to it is that we currently feel it's not our core competence and our core focus, and we rather focus on making sure that we are as compatible as possible with other projects which do make it their focus to provide this kind of reasoning support. Having said that, if you have a reasoner lying around and you think it would be a good addition to RDF4J, we'd love to have it.
Maybe a follow-up question, Morten. Do you have a particular use case at the moment that would require reasoning features beyond RDF as schema?
Well, Yeah, we've been experimenting with rule engines, and then discovered to our horror that the graph database that a different group had selected for us didn't have support for rule engines. But it's like things like where we don't want to have to lay ourselves down upfront in a classification of a certain entity. We would like to be able to do that through the rules, and that's where this would be very handy. So I'm in the security area. You know, the idea of what fast flux is kind of changes over time. We would like to express that as a rule and not as an attribute to that domain. So that's where it would have been useful, as an example.
Obviously, a very important use case. I think it's also maybe a good opportunity to rephrase that question. How do you deal with rule support in RDF4J? What kind of do you support rules, languages, forward chaining, spin?
I can hear Havard grinning in the background. Arguably, Shackle is a rule language, even if the support for Shackle in RDF4J is currently on the constraint validation checking level only, so there's no inference support yet. It is being discussed whether we need that, although not currently a high priority. There is also a spin engine that is part of RDF4J, but it's experimental, and I would not necessarily claim it being production ready. It has scale issues. Then there is some limited support for custom rules by expressing Sparkle queries, which is obviously a forward chaining thing. Again, it's not something that I would necessarily claim is good for very high large scale data sets. Typically I would imagine that, I mean, I don't know the details of Morten's case, obviously, but I imagine that a lot of the things that we tend to want to use rules for can actually often be done by means of a combination of constraint validation and simple application code. And that's what we often see in projects that use RDF4J, I think. So there is some combination sometimes of using the Shackle functionality with just solving these things in application code that communicates with the database. I won't claim that's always ideal, but it is a solution.
And these might be extensions to RDF4J as well.
Yeah, that's definitely an option. But I would even say that just very application specific code can do that thing, because your own domain best, and there's not really. Sometimes it pays off to express things in a standardized formalism, but I've always felt that most of the rule language approaches that are out there are. I'm going to sound uncharitable maybe, but I always felt that they were more trouble than they were worth in the end for the cases that I had to solve with it anyway. But this is maybe something that we can debate at more length over a good drink sometime later, because I'm opinionated about this. Let's say it that way. Let's put it that way.
Next time I'm in Melbourne.
All right. Yeah, you're welcome to it.
Actually, our two speakers are based in Australia. So Holger is also based, I believe, in Cairns. So that was a bit tricky today to actually get the timing right. So we had a focus on the European members of the, there are more than 70,000 members worldwide. So it's tricky to find a good time slot if the speaker is based in Australia. It's it's now late in the evening, I believe, right, in Melbourne.
That's right. Yeah, you're all so far away.
Yeah. It is far away, that's true. But just let me latch on to that previous question, because you mentioned streams. And I wonder, if you have seen an example where someone used the rule language on the incoming RDF streams. And that would be kind of the use case I would foresee for Morton as well.
True, yeah.
I've got to admit, I'm not immediately, and nothing immediately springs to mind. Excuse me for a second. I'm having a issue with my eye.
Okay. Now, I might take a few more questions, so 1 or 2 questions. If there are any other questions in the audience, please raise your hand. If there are no further questions, I will now officially close this event. I would like to thank all the participants for joining us today. I look forward to see many of you again in June for the Shackle session with Holger. All that said, we will continue to have an informal chat now after the actual presentation. So I will unmute everybody. We can just talk amongst each other. So again, thank you very much. Okay.
Thank you. Shall I stop recording at this point?
Yes,
Marco?
please. Yes, please.
All right, I will.